Alright, so we have to multiply. Oh, what just happened? Beg your pardon. Let's see if we can fix this. Sorry for this start. Let's try again. Okay, so hopefully this works this time. So we want to multiply 2.7 by 10 to the power of 6 by 4 by 10 to the power of 9. The secret here, because remember multiplication is commutative, and that means you can multiply things in any order. The secret here is to multiply the regular pieces, the 2.7 and the 4 together, and then multiply the powers of 10 together. We'll see in a second why that's useful, but it's very helpful if we keep the 10s together. Now 2.7 by 4, we can do in our head 4 7s are 28, 4 2s are 8, and 2 is 10, and there will be one decimal place, so it's going to be 10.8. So it's going to be 10.8, and we can put in multiplying signs here if that helps us. Now, the way we add tens, use your rules of exponents here, okay? Rules of exponents. Remember, if the base is the same, add the powers. The rules of exponents tell us that if we have the same base, we just keep that base. So we're going to keep the base 10 and add the powers. Okay, we're going to keep the base 10 and add the powers, so let's do that. So we're going to keep the base 10 and add the powers. 6 plus 9 is 15. So we've got 10.8 by 10 to the power 15. Now, while that looks like scientific notation, it's not, because scientific notation, the decimal point has to be moved until it comes immediately after the first digit. So there can only be one digit after, or one digit in front of the decimal point. So let's take this digit and move it up here. Okay? Now if you're trying to think about what happens to power, okay, if you're trying to think about what happens to power, think of it like this. We had 10.8. We made it smaller because we moved the decimal point forward, and now we made it 1.08. Well, if we make this number smaller, going from 10.8 to 1.08, then to balance it out, we have to make this one bigger. Okay, so that's the simplest way to think about it. So to keep the balance, if we make the first one smaller, we have to make this one bigger. So 1.08 by 10 to the power of 16, that's in scientific notation. Now, this is going to be quite a feat to write this in standard form. So remember, it's 1.08. Now, the power on the 10 is positive. So if the power on the 10 is positive, we're going to move the decimal point back towards the right. Okay, so we'll have lots and lots of zeros at the end, because this number is going to get very, very big. So 1, now the original decimal point is here, 0, 8. Okay, so that's where it is originally. Now we're going to move it backwards 16 places. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11, 12, 13, 14, 15, 16. And then finally we'll put it here. Okay, and hopefully we've done that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And of course, all these missing, all these loops, empty loops, we have to fill up with zeros. So there's quite a lot of writing, and hopefully you won't have to do this too often. Okay, now the decimal point ends up here, which means we get rid of the decimal point that we started with here. And finally, the last thing to do is put in commas. Count 3 from the back. 1, 2, 3, comma. Sorry, 1, 2, 3, comma. 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 So it's 1, 0, 8, blah, 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 blah. Who knows what that is? But that's your final answer in standard form. Okay? Now, rewriting it in standard form is a little bit difficult. But remember, getting to our original answer, 10.8 by 10 to the 15, or even 1.08 by 10 to the 16, was easy, and it makes it a nice, easy way to multiply really, really big numbers. You can see just how big when you look at the final answer. Okay, thank you.